Hello folks, welcome back to Java Object-Oriented Programming. Now we are going to discuss another very important object-oriented programming principle related to inheritance, that is dynamic method dispatch. In the earlier session we observed another object-oriented programming principle related to inheritance, that is method overriding. In that session, we observed the basic mechanism of overriding, but it is not complete about overriding. It forms the basis for one of the Java's most powerful object-oriented principle, that is dynamic method dispatch. This is the mechanism by which a call to an overridden method is resolved during the runtime rather compile time. Suppose I have an inheritance hierarchy like this. Class A is the superclass and B is the subclass. This inheritance hierarchy already we observed in the previous session. Now I have a reference variable called A is of class A. Class A reference variable is A. Now this reference variable can refer to an instance of the superclass. This is very common and very simple. So many times we observe this. Instead of referencing the superclass object, the reference variable can refer to an instance of subclass also. In this context, this reference variable of class A, that is superclass reference variable, when it is referencing to an instance of its subclass, it can only access the inherited members, that is superclass members, but not any members of subclass own. In this context, if you call any overridden method, here for instance you have a show method in the subclass as well as in the superclass, means the subclass is overriding the superclass member method show. If this reference variable called show, what will happen? It causes to invoke the subclass version, that is overridden version, which is on top by the time of overriding, that means overlapping. So this is actually called dynamic method dispatch. Which method definition is to be executed is resolved during the runtime, not during the compile time. Let us try to understand this simple dynamic method dispatch principle in an example. I have a class called A. Further, I am going to make this as a superclass which have only one member method show with a simple display message. This method let us override in the subclasses to observe. Here in the subclass B, I am going to have again the show method, but show of the subclass, not superclass, subclass B. This exact method I am going to have again in another subclass, that is C. Here in C again I am going to have the same show method. In the application, class A reference variable A. Now A equals to new one subclass B, and again class A, the same reference variable equals to new C. When it is referencing to class B object, if I call A dot show, what will happen? Let us observe. When the same reference variable referring to object of another subclass, if I call A dot show, what will happen? Let us observe. But here, before we are calling the A dot show, display a simple message sysout instantiated with subclass B. In the similar way, before calling the same method show with the object of C, again another message, and there is a simple line gap between these two lines. These all are just to make the output more understandable during the runtime. Let us execute and observe what is the result. The superclass reference variable instantiated with B, show method called from the subclass B. Instead, it is referencing the object of C and calling show method. that particular version of the subclass method executed. Already we discussed one point. This reference variable, since superclass reference variable, it knows only about the superclass methods. How to invoke those superclass methods? Suppose here this class B have another method, public void hello. This is out hello. When the superclass reference variable referring to class B object, I'm trying to call a dot hello. You cannot call this method. The reason is a, since it is superclass reference variable, it knows only about the superclass members. It don't know about specific things defined in the subclass. Here, what is a deciding factor whether a method is to be executed or not, can be called or not? The reference variable. The reference variable don't know about hello. But in the case of overridden method, not the reference variable, the object has become the deciding factor from which class this particular overridden method is to be executed. So this is dynamic method dispatch. And one more very important feature of object-oriented programming related to inheritance is what method you are calling here? Show. Again here, show. These two places we are calling the same method, but when this A is referencing to class B object, it is performing one operation. When the same reference variable is referring to another object, it is performing different operation. You are calling the same method, but it is performing different operations, changing from one to another form. This is polymorphism. Here, what is the factor behind this polymorphism? Whether the reference variable or the object. The object is the deciding factor, object created during the runtime. So this polymorphism is called runtime polymorphism or dynamic polymorphism. Now let us try to understand this same dynamic method dispatch which gives the result dynamic polymorphism in another scenario. That is, here I have a use case where I have a couple of 2D shapes like triangle, rectangle, cone and cylinder. Of course, there are so many 2D shapes, but here I have chosen only few of them, which allows us to find the area of that particular diagram using the two only dimensions. So, 2arg constructor, no-arg constructor, setting up the dimensions, calculating area. These are the majorly performed operations across triangle, rectangle, cone and cylinder. Out of these all operations, except calculating the area, remaining all operations are same, but slightly the names of the dimensions varies from one to another shape. In the case of triangle, we call them base and height. In the case of rectangle, we call them length and breadth. Cone, radius and slant height. In the case of cylinder, radius and height. But everywhere, those two are the dimensions. So, set dimensions method is perfectly alright. And the constructors. In the superclass, no-arg constructor makes both the dimensions 0. In the subclasses, calls superclass constructor, and the superclass 2-parameter constructor or 2arg constructor takes two double arguments, dimension 1 and dimension 2. But when the subclass is defining its own constructor, there the specific constructor or the specific class related arguments. For example, in the case of triangle, the constructor parameter names are base and height. In the case of rectangle, the constructor parameter names are length and breadth, likewise. Now, let us try to see how we are going to develop application based on this. I have a shape class reference variable, which is the superclass. Now, this shape class reference variable can be referred to the triangle instance, otherwise a rectangle instance. Sometime later, the same reference variable can be used to refer the object of cylinder class, otherwise the same can refer the cone. But when the reference variable is pointing or referring to which subclass object, that particular subclass version of the calci area method is executed. So here we are going to see this in action. Here let us define triangle, rectangle and shape classes. For brevity's sake, I am not defining all of the subclasses, just only triangle, rectangle, these two only the subclasses. The superclass is anyways shape we have. Let us try. The beans package a class called shape. Finish. This shape class is going to have two parameters of double type, dim1 and dim2. Constructors, public shape, first no arg constructor, which makes dim1 to 0, dim2 to 0, that is clear, and then another constructor, public shape, with two parameters. They are double dim1, double dim2. Now this dot dim1 equals dim1, this dot dim2 is dim2, and then public double calci area. We don't know the number of sides. We don't know whether is it triangle, rectangle, cone or cylinder. Is it possible to calculate the area? No, we cannot calculate the area. In that case, what the double value, the calci area method should return. There is no specific logical value we have to return. So you can just simply return a 0. This is all. We cannot define double returning method without any return value. If this method is not a double method, if this is a void method, the subclasses cannot override with a different signature. In that case, the calci area method in the shape should be a double type method, should return a double value. Since we don't have any double value, we have to return just simply returning 0. Now we'll define another subclass of shape, that is triangle. This triangle class is going to have shape as a superclass. Make sure this shape is from the same package that we defined just some time back. Now in this triangle class, let us define a constructor triangle, that is no arg constructor. What this should do? Just simply call the superclass constructor. Even though you did not write super, the same thing is going to happen. Now public triangle of two parameters, okay, double base and double height. So the base variable should go into dim1 and dim2 should be the height. So we did not define any dim1 dim2 here, but from where they are getting accessed? They are getting accessed from the superclass. Now public double calci area. This method is overriding the superclass method. Now inside of this method, we have to calculate the area of triangle using dim1 dim2 and then return the area. Now double area equals to half into base into height, means 0.5 into dim1 into dim2, that is the area, and then return the area. Finished. In this way we are overriding the superclass member method calci area. Now there is a small tip you have here. We have a doubt whether we are exactly overriding or not. How do we get to know? You put one annotation above the method which you are thinking overriding. So override annotation you put. If it did not show any error here, you are perfectly overriding the superclass particular member method. For example, here, if you have this kind of method, is it really overriding? Not at all. Now, since it is not overriding the superclass member method, but you mentioned override annotation, it shows a wrong error. What is that? You put the mouse pointer here, you'll get to know. The method calcarea of int of type triangle must override or implement super type method. In order to have override annotation, there should be a member method exactly existing in the superclass with this signature. Since it is not there, this is not allowed to have override annotation. Okay, so yeah, I'll remove this int x. In this exact way, let us define another class that is extending again the same shape. The subclass name is rectangle. Let us try. Class name is rectangle, and the superclass name is again shape. Then finish. Here, this class also should have constructors. The rectangle, simply call the superclass constructor, and then public rectangle, another constructor. This constructor is going to have two parameters of double length, double breadth. Now dim1 is the length, dim2 is the breadth. Finish. Now another method, this another method, third method is going to override the superclass method, that is calcarea. This calcarea should return one double value. How we are going to calculate the area into double type variable? In order to return that, let us do double area. Area equals to dim1 into dim2, and then return the area. Now again you test this method also override exactly or not. Finished everything. Both the subclasses we have defined. Now let us go to define the application. Use shape with the main method. Here let us have a shape variable, shape s. Now this shape s equals to new triangle. This new triangle, did you observe the constructor parameters? Base and height. Okay, yeah, base is some random values I am giving. Base is 8.5 and height is 3.6. Then sys out area of triangle plus s dot calcarea. Sys out. Otherwise here directly you can call, instead of calling directly the calcarea, you can declare a variable double area triangle equals to the method call, and then you concatenate that variable area tri. Now an empty line gap. The same lines we are going to repeat. S equals to new. This time we are going to use the rectangle instance. Now in a rectangle class constructor, see the rectangle class has been defined in so many classes, different classes. Here this is our rectangle class. This rectangle class constructor with the two parameters. The first double parameter is length and the other double parameter is breadth. See, length and breadth. Length is same, you may give the same values, 3.6. Now double area of rectangle equals to, again, s dot calcarea, sys out area of rectangle, area rect. Let us observe. See, when the reference variable is referencing to triangle object, it causes to invoke calcarea from the triangle class. In the contrast, when the same reference variable referencing to a rectangle object, it is invoking the override inversion by the rectangle subclass. We are calling the same method s dot calcarea, s dot calcarea. But is it performing the same operation? No. Changing from one to another form, that is based on the object the same reference variable is referencing. Objects are created at runtime. Based on the object, a link between this method call and method definition is established. This linking is called dynamic linking or dynamic binding. The polymorphic effect it is presenting based on dynamic linking. So this is called dynamic polymorphism. The same thing I have presented here. When the shape S reference variable is referring to triangle object and called calci area, triangle version of calci area is executed. In the contrast, when the same shape reference variable is referring to an instance of cylinder class and called the calci area, this time cylinder version of overridden method is executed. This is dynamic polymorphism and the most powerful object-oriented programming principle. And now I'm winding up this session with a small question. If someone created an instance of shape, new shape, and called the area, of course dimensions also are there, and what is the area? Is it have any meaning? We'll discuss all these things in the upcoming session, and thank you for watching.